Welcome to this video. In this video, I will continue to talk about questions involving proof. Okay, so in the previous video, I showed you guys how to solve a proof question by making my left-hand side equal to my right. Make the left-hand side to look exactly as my right-hand side, and when I'm done with that, I have completed the proof. There is another way of doing this, okay? And this might be the easier way, okay? This method involves all of the identities that we have talked about. In fact, we are actually trying to manipulate whatever we have. We're trying to manipulate what we have here to make them look like one of them. One of this, especially 1, 2, especially this one, sorry. That one right there, sine squared theta plus cos squared theta equals to 1. That is what we are actually going to go for, okay? So let's try to change this whole chunk in that to that, okay? Right, let's get started. So again, we have to manipulate our whatever we have right now. So let's see. So if on the right hand side I'm trying to get that 1, which means I don't want that to be there. Make sense? So I'm gonna bring that over to the left. So I will have 1 plus tangent square x cos 2x plus tangent square x is equal to 1. So on the left hand side, I need to change that to become sine square x plus cos square x. If I can somehow make the entire left hand side, because I already got this equal to 1, I already got that. So if I can somehow make the left hand side, what I have here, the very long chunk that I have here, make that equal to sine square x plus cos square x, then my proof is done. But now here comes the tough part. Let's see what we can do. This would not be always true, but it is often it is worth a try. I'm going to break the tangent into sine over cos. So the tangent square x becomes sine square x over cos square x, and the cos 2x stays there, and this will also be changed. Equals to 1. Okay, and now let's see what we can do. I'm going to distribute the cos 2x there. Oops. Cos 2x and there as well. So distribute them, I will get cos 2x plus sine square x over cos square x multiplied by cos 2x. And I mentioned in the previous video, please do not simplify them, okay? You can't do that. You can't. They're not the same thing, right? It's not a matter of power, it's a matter of the angles, okay? Alright, so let's see what we got. Let's see what we have here. For now, the denominator, it seems a bit annoying. So let's see if we can do anything about it. What can we do? Let's try to, because on the left hand side, I'm gonna break it down into sine squared and cos squared. Sine squared and cos squared. Alright, I'm kind of stuck at the moment. I'm gonna pause the video and I'm gonna try some stuff out on paper, and then I'll come back, okay? Okay, wow. Alright, I paused the video just now so that I could figure out where to go next, and I got it. Okay, so let me show you guys how to proceed. So at this point, I'm going to keep the cos 2x the same. And for the sine square x over cos square x, I'm gonna keep that the same. However, my goal is to get this, right? We need to get this sine square plus cos square, which means I don't want to have any denominators, which means my cos 2x over here, my cos 2x there has to be modified. It has to be changed in a way that this is going to be cut out, which means I will have to change my cosine 2x into 2 cos square x minus 1. Right? So I'll multiply it by 2 cos square x minus 1 plus sine square x over cos squared x is equal to 1. Okay, so I've just changed this to that, and the reason why I chose 2x squared x minus 1 is so that when I distribute later, the denominator will be cancelled. Okay. So if I distribute the first part, the cos square x and the cos square x will cancel, they'll go away. I'll get 2 sine square x. Okay. If you're not sure, you can write this on the side. Sine square x over cos square x multiplied by 2 cos square x. So cos square x, for sure we can cancel them. When we cancel them, we get 1. So that gives us 2 sine squared x. Okay, let me erase that. So if you need to rewatch that, please feel free to rewind. Okay, so that's the first part. Now the second part, I get minus sine square x over cos square x plus sine square x, that's just over cos square x, that has been there the whole time. And I'm not sure if you realize something. Yay, I can cut them out. Minus, plus, and I can just cancel them out. Beautiful, right? So I have cos 2x plus 2 sine square x is equal to 1. Now, I am a little bit closer to what I want over here, right? What I want, this is our goal, right? So I'm a little bit closer to my goal now because at least I don't have any sort of denominator, and everything is in sine and cosine, right? So I need to change this. I already have a sine square there, even though I have a 2, but maybe I can deal with the 2 later on. But for now, the more important thing to deal with is this cos 2x. And hopefully I'm trying to get this cos squared, right? I'm trying to get that cos squared. So I'm going to change the cos 2x to become 2 cos square x minus 1 plus 2 sine square x, that's not changed, equals to 1, and that's not changed either. Now I have minus 1, let me bring it to the other side. So I have 2 sine square x, 2 cos square x plus 2 sine square x is equal to 2. And this is awesome because what I can do now is divide everything by 2, divide every single thing by 2, then I will get cos square x plus sine square x equals to 1. And this is the exact identity, right? The Pythagoras identity. Okay? So there you go. By proving the Pythagoras identity, I think some people say they call it the Pythagorean identity in the formula booklet. We have shown that the proof is true. This is true because we could get the Pythagorean identity. So this is one way of solving proof questions. Okay, so we can either, as shown in the previous video, make your left-hand side to look exactly the same as your right-hand side. You have to make the left-hand side, this whole chunk, to look exactly the same as your right, or you can change this whole thing and make that into show that it will give you this Pythagorean identity. Alright, questions involving proof, they are challenging, and sometimes if you get lucky, if you choose the right things to be substituted, or if you choose the right identity, then your steps would be a lot shorter and a lot easier. If you look at what I have over here, this is actually example 10. This is example 10 in the textbook, right? Example 10. And you can see that my approach is quite different from what they showed you in the textbook. So feel free to take a look at the example 10, and good luck. I'll see you in the next video. Bye bye.